This is the MAT140 lesson number 9 on solving systems with matrices. The example says, the Walters Manufacturing Company has 3 types of sheds that it produces, type 1, 2, and 3. And producing each type of shed requires different amounts of time for stamping and painting and packaging, as given in the table. The Walters Company has a maximum of 6,600 hours for stamping, 3,900 hours for painting, and 2,500 hours for packaging during each of its production cycles. The table is given, and the question says, write an augmented matrix that will allow the Walters Company to determine the number of each type of shed they should produce that will exactly use all of the time available in each department. Alright, to answer this first question, let's write over on the side over here what these maximum hours available for each of the departments are. So for stamping it says 6,600 hours. For painting it says 3,900 hours. And for packaging 2,500. And now to explain where this augmented matrix comes from, I'll just back up a little bit and write a few extra steps that ultimately you wouldn't really have to write to answer this. But I want to explain where that answer comes from. So, what we're trying to do is figure out how many of each type. So let's say X is the number of type 1. Let's make Y the number of type 2 sheds. Now, knowing that for stamping it takes 3 hours for a type 1 and that it takes 4 hours for a type 2 and the type 3 shed takes 5 hours for the stamping process, we could write an equation and say 3x plus 4y and plus 5z, and that would equal 6,600. Or at least we're going to try to find the x, y, and z where we do get 6,600. In other words, if we made just one of these type 1 and only one of the type 2 and only one of the type 3, that would take 3 hours plus 4 hours plus 5 hours. That's 12 hours of stamping, and of course we got a lot more. We got 6,600. So looking at x, y, and z as being the number of sheds produced, and each of those different types of sheds taking different numbers of hours, we'd have to multiply the number of hours required for each type and add all those hours together, because these are the amounts of hours required total, depending on the number of sheds, the number of type 1 sheds, the total number of hours for stamping of type 1 and the total number of hours of stamping of type 2 and the total number of hours for stamping of the type 3. And anyway, that's the total number of hours of stamping that would be required for a given number of sheds, and we want that to equal 6,600. And then you'd use the same logic on the next line. You could write another equation just for the category of painting, looking at how many hours each type required. We can read off the table. 4x, 3y, and 1z. So given the numbers of each type of shed and the number of hours you'd have to multiply that by for the painting, that would give you that expression. And you know that we want to be equal to exactly 3,900. Finally, we got this last row where the packaging requires 2 hours for each type 1, and it requires 2 hours for each type 2, and it requires just an hour for each of the type 3, and so this is the total number of hours for the packaging process. And we can go up to 2,500, and we're going to look for a value of x, y, and z that exactly satisfies all 3 of those equations. So that's the system of equations that we want to solve, but we can solve this using a matrix. And specifically, we can write a matrix for just the coefficients of the equations, but if you include this column on the right hand side, we can use that in the calculator, or even if we were doing this by hand. If we were doing this by hand, we would do this process. Well, you could use several different techniques to do it by hand. But this is perfect for doing it on a calculator or a computer. And you'll definitely want to do it on a calculator because you'll need to do that on a midterm where all you have is a calculator. You could also learn how to do it on the computer. That's a very useful skill as well. And you could check the results and compare and understand the process a little bit more generally, being able to do it on both computer and calculator. So anyway, the augmented matrix is just reading off those numbers. Just copy that last column after the equal into the last column in your matrix, and it's just understood that there's an equal. If you say this is an augmented matrix, we just know the last one is the number after the equal. So the word augmented refers to the fact that we're adding on this column of constant values that are to the right of the equal in the system of equations. If we didn't include that, we would just call it the coefficient matrix, but putting them together, it's called the augmented matrix, and you can use that augmented matrix on the calculator to solve the system. That is, to find the values of x and y, x, y, and z that would solve all those equations simultaneously. Okay, and I almost missed it, but that says 6600, and I gotta fix that now. Okay, so that's augmented matrix. Let's move on. Solve the system, write the final reduced row echelon form of the augmented matrix below. You can solve by hand or use a calculator or Excel or some other computer application. So you definitely need to learn how to do this by the calculator because that's what you'll want to go quickly on the exam. You don't have to do it by hand. There's some videos on the MyOpenMath homework on how you do this by hand. That would be a topic that if we were studying a little more on matrices, maybe we'd have time to go into that. It's something you would do in a class called linear algebra. I think with the overall picture of what we'll try to accomplish, the details of how to do it by hand are not my priority here. So you can use the calculator. Again, that's what you'll really need primarily. You can also do this on the computer. It's really easy and quick, and it's nice to see how it works on the computer also. Let's do it by the calculator first here. So this is the augmented matrix, which I actually have to type into the calculator. Okay, so I've got my calculator up and running, and I'll go into the matrix menu to enter in the augmented matrix we have. And I notice, well, there's a bunch of matrices in there, which I could just type over and just keep going, but it might be useful sometimes that you want to clear these things out. So let me show you how you do that. There's a button right here that says MEM for memory. So let's go to that second mem, and let's go into, well, I'm not completely sure which one it is. I might be number 3 or number 4. Let's try 3. Clear entries. I'm not sure about that. Let's try again. Second memory. How about clear all lists? Number 4. Oh, you know what? Actually, it's probably 2. Let's go there. Yep, you see that? I have number 5 on the list, matrix. So let's just type 5. And then here I can actually tell it which ones I want to delete, and I want to delete them all. I think if I hit clear, nope, sorry, mem number 2, matrix, how about del? Yep, see that? I'm hitting delete, and they're disappearing. It's increasing the memory in the calculator, not that that really matters, but anyway, they're gone. And now when I go back to the matrix menu, it's all cleared out. If you want to do that. Okay, so I really need one matrix here, and it's this one, the augmented matrix. Let's type that in. So edit. This is a 3 rows and 4 columns, so 3 by 4. Because it was a 3 by 3 coefficient matrix, and it's got that last column, makes it 4 columns. So 3 by 4. Going along the top row, 3, 4, 5, 6600. Now going along the second row, and now finally the bottom row. Okay, so then you'll have to quit from that to do an operation on that matrix. So let's quit from the editor. Second, quit. And then go back to the matrix editor, and in the menu for the math operation, so I just scroll over one, you can scroll down or just scroll up from the top. It'll start down at the bottom. The one that I want is this option here. This is for reduced row echelon form. Reduced row echelon form, you can read solutions to linear systems. So let's do that. I'll talk about a little bit about what it means, but we're going to perform this operation on this augmented matrix. So the matrix, what you have to now indicate which matrix you want to do the operation on, and of course it's matrix A. So go back to the second matrix, and then the name of the matrix is that I want to do this. I want to refer to matrix A, so just hit enter, and then enter again. So that's it. Reading off the calculator there, the results that I got were 1, 0, 0, 500, 0, 1, 0, 400, 0, 0, 1, 700. So what's happening is we've taken this matrix and through a series of what are called row operations, which rewrite the matrix in equivalent matrices that have the same solution, it's transformed into this form. But it still is an equivalent matrix, which means it still has the same solutions. And if you think about what the original matrix that we wrote really represented, we could translate this back into the actual equations that to which it would be corresponding. And so putting it back as an actual equation would mean you'd have 1x plus 0y and plus 0z, and that would equal 500. From this equation, reading the second equation, it would be 0x and 1y plus 0z would have to equal 400. And then finally, in the reading off the last row, 0x, 0y, and 1z, that would be equal to 700 from translating this back into an equation. But then if you read these equations, they're very easy to solve. The only thing that makes the first one true is x equal 500. The only thing that makes the second one true is y equal 400. And the only thing that makes the third one true is z equals 700. So what's happened is we've turned the given matrix into this equivalent matrix from which we can read the solution. So that's it. That's the answer. 500 of the type 1, 400 of the type 2, 700 of the type 3. So actually, this is really question 3, I think. How many of each type of shed should the company produce to exactly use all of the available time in each of the departments? Because we have x equal 500, we have y equal 400, and we found z equals 700 would satisfy all of those equations that we originally wrote. 500 type 1, 400 type 2, 700 type 3. And that's the end of that example. I hope it's been helpful. We'll move on.